Hello everyone, welcome to my channel. Today we are going to solve Leetcode problem number 124, that is binary tree maximum path sum. So basically we are given the root of a binary tree and we need to find the maximum path sum of a non-empty path. So let's see the intuition. So let's first understand what makes this problem tricky. So at a first glance, we may think that every maximum path should pass through this root node, but that's actually not true. So if we force the path through the root node, one possible path is going to be this 15 plus 20 plus minus 10, which is going to be 34. But there is an even better path. That is, the maximum path is 15 plus 20 plus 7. That is going to be 42. So if we're going to notice that this path doesn't even touch the root node, that's why a simple root to leaf approach won't work. So at every node, we need to ask ourselves two questions. That is, what is the maximum path that one passes through this node, right? The root node. And what value should I return to my parent node? We can also consider this as a root node, right? So we can also check that what is the maximum path that passes through this node, right? So let's focus on this 20th node. So its left side contributes 15 and its right side contributes 7. So if I use both sides together, so basically we're going to get 15 plus 20 plus 7, which is going to be 42. And this creates a complete path, which is going to be like this. And we want this path actually. So this is a candidate for a final answer, right? Which is going to be 42. Now suppose node 20 want to send its value to its parent node, which is this minus 10, right? So can it return 42? Can it return 42? Because we have this root, right, which actually gives us some 42. So should we have to return 42 to its parent node? So no, right? Because 42 uses both left and right branches, right? If parent also add another branch like this, so this path would split it into three directions, right? Which is actually invalid, right? So to continue upward, we can only choose one side, either 15 plus 20 or 20 plus 7. So we have to choose this branch or this branch, right? We can't choose this both of this, right? So the node going to return and it is obvious that we're going to choose the larger one, which is this 15 one. So our node going to return 35, right, which is going to be 20 plus 15, which is going to be 35. So we're going to return 35 to its parent node, right? So this gives us the key insight of the entire problem. At every node, we're going to use the left plus node plus right to the upward answer, right? Then we're going to return the maximum of left or right to its parent node. So let's see the coding part. So first we're going to create a global variable called maxi. So I'm going to write self dot maxi, which is going to store a minus of infinity. So I'm going to write over here float of minus infinity. because they store the maximum path sum which is going to be found in our tree. So basically we're going to put this negative infinity, because node value can also be negative. Then we're going to create a helper function which is going to be def. I'm gonna name them solve, and then we're going to pass one parameter which is going to be node, and then we're going to check if the node is going to be null, so there is no contribution to the path, and so we're going to simply return 0, right? So if node equals to none, yes, then we're going to return 0. Okay, now so we need to add the left and right contribution. So for that, I'm going to make a variable left sum where we're going to store maximum of 0 comma. We're going to call this function, and we're going to pass node dot left, which is going to traverse the left side of our tree. Then we're going to calculate the right sum, which is going to be max of 0 comma solve of node dot right. So you might wondering that why I'm taking 0. So this is the most important part here. Solve node left gives the maximum gain from the left subtree. Similarly, this right sum give the maximum sum from the right side. But what if the gain is going to be negative? So at a negative path will only going to decrease our answer. So instead of taking a negative value, we're going to take 0, right? So this means either uses that subtree or completely will going to ignore that tree if the node value contains negative value, right? So in that case, we're going to simply return 0. We're not going to consider the negative value, right? Because it's only going to decrease our answer. Okay. Then we have to calculate our maxi, which basically store the maximum sum. So self dot maxi going to store max of self dot maxi, that's the previous value of maxi. Then we're going to add the left node plus the root node, which is going to be node dot well, then the right node sum, which is going to be rs, right? Then we need to return something to our parent node, right? So we're going to write return node dot well plus we have to return the maximum from the left side or from the right side. So it could be max of left sum or right sum, right? So basically we are going to return both from left and right gain, right? Because the parent can only continue one path upward, right? So if we return both sides, the path would split it into multiple branches, which is not a valid answer. So we return current node plus maximum of left gain and right gain. Then we need to call this function. So we have to write solve of root. Then we need to return self.maxi. Now let's run this code. Accepted. And now let's see the dry run of this code. So basically we have this a simple binary tree, and according to this code we need to pass the root node, right? So we're going to take -10, which is our root node. Someone write over here -10, right? So is this node is null? So this node is not null. Then we're going to calculate the left sum, which is going to be maximum of 0 if that node is null. Otherwise we're going to call this function, and then we're going to traverse the left side. So we're going to call this function, and the left side of this node is 9. Then we're going to pass 9. Then we're going to check again, no, this node is not null. Then again we're going to call this function. This time we didn't have a left node, so we're going to return 0 value. So I'm going to write over here 0. Then again we didn't have a right node, then again we're going to get a 0. Then our maxi going to calculate the maximum sum, which is going to be self.maxi. So self.maxi is initially -infinity, right? Then left sum plus node.well plus right sum. So left sum is 0, node.well is 9, and right sum is again 0. So basically maxi is going to be 9, right? Then we need to return to our parent node, which is going to be node.well, which is our 9 plus max of left sum plus right sum. So left sum is 0, right sum is 0, which is going to be 0. Node.well is 9. So basically we're going to return to this function back, which is going to be 9, right? Then we need to calculate the right sum, which is going to be max of 0. Solve.node.right means we need to traverse the right side. So we're going to call this function again. So what is the right node, which is going to be 20? So this time we're going to pass over here is 20. So 20 is not a null node. Then we're going to calculate the left sum. So I'm going to rub this so that it becomes clear. So we need to calculate the left sum. So we're going to call this function again. This time what is the left node for this 20th one, which is going to be 15. So I'm going to write over here 15. So 15 is also not a null node. Then we're going to calculate the left sum for this 15th node, which is 0, right? We didn't have any other node. And right sum again 0, so we get 0, 0. Then self.maxi is equals to max of maxi, comma, left sum plus node.well plus right sum. So left sum is 0, node.well is 15, and right sum is 0. So basically we have 15. So it will going to, and then we're going to return to a parent node, which is going to be node.well plus maximum of left sum or right sum. So left sum is 0, right sum is 0. Then we're basically going to return over here is 15. So left sum is going to be 15. Similarly for the right sum, which is going to be 7, right? So again we're going to calculate maxi, which is going to be the previous maxi, which is we have 9. Then left sum is 15, node.well is 20. Then right sum is 7, which is actually equals to 42. So we have, so maxi contains 42. Then we need to return node.well plus max of left sum or right sum. So node.well is 20, maximum of left sum or right sum. So maximum is going to be 15. So 20 plus 15 is 35. Then here we're going to return 35, right? Then we're going to calculate self.maxi is equals to self.maxi, the previous one is 42, then left sum plus node.well plus right sum. So left sum is 9, node.well is -10 plus right sum is 35, which is obviously less than the previous maxi sum. So our answer is going to be 42. So this is how our recursion going to work in this problem. And now let's move to the code, and this time we're going to submit this code. So let's submit this code. And submit it. So this is how we need to solve this problem. and I'm going to see you in the next video. Bye bye.